So, rates of change.
Yeah, it's chapter 8 of core 1, and rates of change sounds familiar actually.
Yes. I think it's pretty much just like gradient, isn't it?
Gradient?
Yeah.
Well, that's just m in y equals mx plus c later.
Oh no, but Wayne. So, if it's that easy, what's the gradient there?
Oh, it's just y equals mx plus c with a quadratic. You just. I guess that's why it's a new chapter.
Yeah, it's a bit different. So, it is actually quite simple. You do something really jazzy called differentiation.
Brand new stuff. And it's all about finding the gradient at particular points on a curve. So now, rather than it just being as simple as m, you've got to individually work it out with this new differentiation.
Absolutely. There's a few ways of writing how to differentiate. There is dy by dx and f dash x. But first of all, how do we do it?
Well, it's actually really easy, and it's not always quadratics. It can be something like y equals 4x cubed, which is a cubic, plus 2x squared plus 3x plus 4, say. That would be drawn and it would say, what's the gradient at this point? First you do the dy by dx. Now this is new.
It is new.
So to answer your question, Triff, what you do is you take the power, times it by the coefficient, then reduce the power by 1.
That's really for all of the things here.
So it would be 4 times 3, lots of x, reducing it by 1 squared, and then plus 2 times 2, reduce the power by 1 from 2 to just 1. Here it's just 3 times 1, and x to the 0, and the 4 just disappears because there's no x, there's no power. It's essentially x to the power of 0 times anything by 0, it's gone. So you just ignore normal constants. So then that would be 12x squared plus 4x plus 3, because anything to the power of 0 is 1, it just becomes 3.
It does. Summarising algebraically, if you have a to the ax to the b, be ab x b minus 1.
And that's lovely. So if we have this example, and it's a quadratic, let's just say it's y equals x squared minus 4, because that's what it looks like. It looks like it's just been reduced by 4.
And they ask you to find the gradient at this point, and they give you the point, and they say it's
X equals 2, maybe?
Yeah, x equals 2.
What's the gradient at this point? Essentially what you're doing is finding the tangent to it at that point by differentiating.
Yeah, so you differentiate the whole equation.
Yep. And we've just learnt how to do that.
Yep.
dy by I'll use the other notation just because I've already used dy by dx.
Yeah. It means the same thing, just one's by different mathematicians.
Yeah. And it equals, you take that to the front and times it, so
Yep.
it would be 2, and then reduce the power by 1.
X. And our coefficient things about x's just disappear.
Yeah. As I've just explained, it would just be to the 0 and it would go.
Yeah. And then we put our point in here, like x equals 2, we put into this equation.
So then it would be 2 lots of 2, which equals 4, and that would be the gradient at that point.
It would. And they give you any other point, you just put it into that same equation. So it's pretty much as simple as that.
It is, and we've said this very quickly. This is called the first derivative. There is the second derivative, which is chapter 9. The two chapters go together, but we're separating them anyway to avoid confusion.
Yep, and I think we should go straight into a test yourself question.
We should, so let's get it going.
Alright, question time.
Test yourself, page 123, question 1 from this book.
Absolutely.
There wasn't a lot of choice because it's a really short chapter.
There's only one exam question in there.
Yep. And we always try and do an exam paper where possible. So this is 2002, could come up.
Alright, so here we go. It says, 1a, express 3, open bracket, x plus 1, close bracket, squared, in the form px squared plus qx plus r. So it's just going to ask you to expand it.
Which is a really easy part 1, but it's come up in an exam.
Yes, and I'll do this in 2 steps, I think.
I do the squared bit first, then times it by 3.
That was my 2 steps.
I nailed it.
Yeah, so you do a big bracket, so you'd have x squared plus 2x plus 1.
You should get fairly fluent at expanding these.
Yeah.
And it's 3 times each thing.
So you have 3x squared plus 6x plus 3. And that's part A. Pretty simple.
If you really wanted to, you could just clarify to make it crystal clear to the examiner. P equals 3, Q equals 6, and R equals 3, but that's not necessary.
Not necessary. And you have part B. Alright. So, find the gradient of the curve with the equation, what we have here,
Find
at the point x equals 4.
Well, I think you got off easy reading 2 questions. I'm going to make you do part B, and I'll just hold the book and pretend I read it to you.
Well, there you are. Let's swap places. So we need to differentiate what we have here. So I'm going to use dy by dx because I prefer that.
Yeah, the f-x is normally for functions, and this isn't a function.
This is
it's
a function.
Y equals. Functions are in core 3. You got that to look forward to.
Yeah, that'll be incredibly exciting when we get there. So we times by the power and then decrease power by 1. So it'll be 2 times 3.
Yep.
Which is 6.
And then it's just x to the 1. You don't put to the 1. You can just put 6x.
This pen's rubbish. I'll swap to a different one.
Alright. Next we've got 6x to the 1.
Yep. So times by 1, 6. Then that's a 0, so it disappears.
Yep. And this is 3x to the 0. Anything times by 0 is 0, so that disappears.
Yep. And that's the end of that. So now we have our equation. We need to put in the 4.
Yes, and that finds the gradient of this at this point, which is really clever, I think.
I think it's lovely.
6 times 4 plus 6. 6 times 4 is 24.
So equals 30.
It equals 30 is the gradient,
Which
is
is
a very steep
It is
gradient.
a very, very steep gradient.
And there was only 2 parts. Yes.
That's it.
This chapter was very, very small.
So
It links directly in with chapter 9, so you can really think of it as them combined, but we separated it anyway.
we did. If you have any questions, of course, you can send it to our Facebook channel.
We can send it to our channel, or our Facebook page, or our YouTube page, or our Facebook YouTube, whatever.
Whatever works. And we'll send a reply.
Yes, because we've just whizzed over it because it's revision.
It is revision. So with that in mind, let's get on to differentiation properly.
Yeah.
Oh yeah.